the starry night, we're actually looking into the past by 4 years or more. Mostly, much more. For example, let us turn our mind's eyes towards the Orion constellation. The star pattern is most notable for a band of 3 distinct stars that form a line. To the ancient Greeks, this line marked the belt of a mythological hunter named Orion. Within this constellation, we encounter the Orion Nebula, whose light takes 1,500 years to reach us. This means that when we look at it now, we are actually seeing how this nebula looked around the year 500. As for the Phantom Galaxy, our glowing spiral from the beginning of this story, it is 32 million light years away. In other words, that Webb telescope image shows the galaxy as it was 32 million years ago. Long before humans walked the earth, or gazed at the heavens, or conceived of creating instruments to examine the stars, scientists are using the Webb telescope's phantom galaxy images as part of an effort to discover more about how stars formed during the earlier days of the universe. The telescope's clearer observations will help them get a read on just how old the stars in these galaxies are. They can combine the Webb data with material gathered by other Earth-bound telescopes. Together, this information will allow us to learn more about the formation of the universe than ever possible before. But the first inventors of the telescope weren't thinking about looking back in time, and they had no conception of how vast and ancient our universe truly seems to be. Instead, early telescope makers wanted to examine the visible sky in greater detail. They wanted to look closer at the objects they could already see at night, including our own moon and closest planetary neighbors. These remained great mysteries at that time. Meanwhile, the farther out planets of our solar system hadn't even been discovered yet because they weren't visible to the naked eye. Humans had observed the night sky since before history began, watching the stars and weaving intricate tales about them. These stories included myths that live on today in the names of constellations like Pisces and Orion. Some ancient people made more methodical observations of the stars too. They kept complex records and even formed accurate predictions about celestial movements. Then, several hundred years ago, the advent of the telescope brought the cosmos into focus in a whole new way, launching modern astronomy on a sky-high trajectory, quite literally. Here's how it began. Around the start of the 1600s, craftsmen in the Netherlands were making advances in creating eyeglasses to allow people to see better. They drew on knowledge about the science of optics that had been developing throughout the Middle Ages. Various scholars and innovators had made advances in the area over the prior centuries. These included the Islamic scientists al-Kindi in the 9th century and Ibn Sahl and Ibn al-Haytham in the 10th, as well as the English Christian friar and scientist Roger Bacon in the 13th century. Inventors in Europe began to use lenses to magnify objects and make them appear closer than they were. In 1608, several different spectacle makers in the Netherlands created what were essentially the first telescopes. However, these were intended for earthbound use. Something like a spotting scope or binoculars, not for observation of the cosmos. They were referred to as perspective glasses, and they magnified objects 3 times, making them look 3 times larger or closer than they looked normally. The fact that several different spectacle makers created these perspective glasses at the same time highlights the reality that they were drawing on a significant amount of existing knowledge in the field. At the time, however, it led to battles over who would get credit for the innovation and wealth from it. 2 spectacle makers in one town, Hans Lippershey and Zacharias Janssen, both developed prototypes, leading to some claims that the former stole the idea from the latter. Lippershey filed a patent for this instrument for, as he described it, seeing things far away as if they were near. A few weeks later, another lens maker from another part of the Netherlands named Jacob Matthias applied for a very similar patent. The government of the Netherlands turned down both patent applications, but paid Lippershey a good deal of money to create binoculars using the technology. The developers of these early telescopes saw them as useful for observations on Earth, such as for surveying land and conducting military surveillance. Certain pioneering astronomers, however, saw the value of these Dutch perspective glasses for revealing the heavens. Among them was the revolutionary scientist Galileo Galilei, living in what is now the country of Italy. Galileo heard reports about the new perspective glasses the year after the rival patents were filed in the Netherlands. He immediately came up with his own, slightly different version. Soon, Galileo found a way to modify his design so that his telescope magnified objects to 8 times their size, rather than just 3. This was a necessary improvement if they were to be used to observe objects very far away, like in space. By the end of that year, he created an instrument that could make objects look 20 times larger than when they were viewed with the naked eye. Eventually, he would succeed in creating a telescope that could magnify 30 times. Galileo was reportedly the first to point his telescope upwards to gaze into the mysteries of the night sky and publish his observations of space. The powerful new instrument allowed Galileo to publish new discoveries, like Jupiter's 4 largest moons and sunspots on the surface of our sun. Galileo demonstrated his telescope in Venice to great success and was rewarded with a lifetime position as a lecturer. Galileo's largest telescope had a lens just 2 inches wide, and even his instruments, which were so much more powerful than those made in the Netherlands, were weak compared to today's incredible technology. But with these rudimentary tools, he made groundbreaking observations. Through his simple telescopes, Galileo observed the Milky Way, that pale band of white that's visible across the sky after the sun sets. And with them, he was able to discern that this previously mysterious Milky Band was actually made up of many individual stars. It wasn't some kind of fog or celestial milk. It's our galaxy. Galileo also turned his scopes on the moon, where he saw mountains and valleys, though no sign of the fabled man in the moon. His documentation of the lunar landscape countered the common belief of the time that the moon was a perfectly smooth ball. Galileo was able to observe the planet Jupiter and discover its 4 largest moons as well, which are invisible to human eyes without help. A rival astronomer, Simon Marius of Germany, also spotted these moons around the same time, and he gave them the names by which they're known today. He named them Io, Europa, Ganymede, and Callisto, after characters from Greek and Roman mythology who were associated with Jupiter, the king of the gods. Following the trailblazing inventions and observations of Galileo, the Dutch spectacle makers, and their contemporaries, many other scientists continued developing new and better telescopes. They came up with ever more powerful ways to magnify celestial objects, and soon they were able to start observing phenomena in the outer reaches of our solar system and beyond. They created larger and stronger telescopes. With these, they could witness more and more details in space that had formerly been invisible and unsuspected. They uncovered hitherto unknown planets circling our sun, far away from the Earth. For example, at the end of the 1700s, astronomers found the distant planet Uranus. They observed this newly discovered planet and carefully recorded its motion. In doing so, the scientists noticed that its orbit around the sun was irregular in ways they couldn't fully explain. As they examined its odd orbit, however, they realized that it could be explained if there was an even more distant planet, as yet undiscovered, whose gravity was pulling on Uranus. So, some of the scientists set to work, calculating where such an invisible planet might lie. In order to have the gravitational effect they'd observed on Uranus's orbit, their calculations proved impressively accurate. And sure enough, in 1846, an astronomer in Berlin observed a brand new planet in just about the spot they'd calculated. The newly discovered planet was named Neptune, after the ancient Roman god of the sea. Neptune was too far away to be seen from Earth without a telescope. It circled the sun in the lonely outskirts of the solar